Study Session 8, Essentials of Experimental Research. Introduction. The purpose of this study session is to expose your research language in psychology, which is necessary for you to master if you want to read and write about psychological research. Learning outcomes. When you have studied this session, you should be able to define and use correctly all of the key words printed in bold. Problem, sampling, hypothesis, descriptive statistics, and inferential statistics. Issues in conducting an experiment. One problem for the new researcher is related to the law of the laboratory. Everybody knows there are certain obvious ways to perform certain kinds of research. These ways differ from area to area, but are well known within each category. They are so well known that researchers seldom bother to explain them. Indeed, they are quite surprised when new researchers are ignorant of these obvious methods and techniques. Animal researchers often deprive animals of food for several hours before the experiment, or keep their pigeons at a certain percentage of the weight the pigeons would attain if they had food continuously available. Although the reasons for this are obvious to the researcher, they may not be obvious to you. How does an experimenter know how many items to use in a memory experiment? How long should an experiment take? Why is one dependent variable selected from a set of what appears to be equally valid dependent variables? The next sub-session will answer the questions from problem to experiment. All research aims at solving a problem. The problem can be abstract and theoretical, or concrete and applied. The problem may arise from an observation made more or less casually, such as that people seem to be more aggressive during the summer. Here, the problem can be stated as, why does summer heat cause aggression? Or more skeptically, as does high temperature cause aggression? A problem may arise from an accidental discovery in a laboratory, such as finding of mold on a piece of bread. Solving this problem, why is the mold growing here, led to the discovery of penicillin. Finally, a problem may arise directly from a theoretical model. For instance, when we ask, why does reinforcement increase the probability of the occurrence of the behavior that preceded it? From problem to hypothesis. A problem is more or less a vague statement that must be verified or a question that must be answered. Unless either is made specific and precise, it cannot be experimentally tested. Any hypothesis is a particular prediction derived from a problem, often stated in this form. If A, then B. The crucial distinction between a problem and a hypothesis is that a hypothesis is directly testable, whereas a problem is not. An experimental test must be capable of disproving a hypothesis. The purpose of any experiment is to test a hypothesis about the effect of an independent variable or variables on the dependent variable. To do this, we must collect data. Once obtained, this data must be analyzed. Once analyzed, data must be reported. These aspects are briefly discussed in turn. Obtaining data. Outlining an experimental design does not establish all the conditions needed for data acquisition. Although the design tells you how to assign subject to experiments, It does not tell you how to get the subjects. Without subjects, there are no data. Psychologists who investigate animal behavior have much more control over subject selection than those who study humans. Although animal psychologists must bear the additional expense of obtaining, housing, and feeding their subjects, they can select the strain they wish to purchase and always have subjects available, barring some catastrophe. Research with humans most often uses as subjects college students enrolled in introductory psychology. Provided that his participation is used as a learning experience for the students, it is considered ethical and proper. APA 1973. If the experiment is not used as a learning experience, the experimenter should pay subjects. Since college students are a selected population, experimenters need to be careful about generalizing results to other subject populations. For example, techniques from a programmed learning system designed to teach inorganic chemistry might not prove successful in the teaching of plumbing. The technique of selecting subjects from some population is called sampling. Sampling is necessary because it is usually impossible to test the entire population, say all college sophomores in the United States. Random sampling means that any member of a population has an equal chance of being selected as a subject. Furthermore, each selection is independent of other selections, so that choosing one person does not affect the chances of selecting anyone else. Since a typical researcher does not have access to all college students, the experimenter tries to select randomly from the population that is available to him or her. Often, even this step is impractical, so the researcher can only randomly assign subjects to the various experimental conditions. After your sample has been selected and your design is fixed, one major decision remains. Should you test your subject one at a time or in a group? Both procedures have advantages and disadvantages. The biggest advantage of a group testing is management of time. It is faster and therefore better to test subjects in group. But there are many instances where all other things are far from being equal. For example, take a listening experiment in which separate words are presented to the left and the right ears. One hurried doctoral student decided to save time and test her subjects in a group. She forgot that unless subjects were positioned exactly between the two loudspeakers, one message would reach one ear before the other message reached the other ear. This invalidated the independent variable. Of course, it would have been fine to test subjects in a group if each subject wore earphones, thus avoiding this difficulty. The other problem in a group testing is the possibility that subjects will influence one another, thus influencing the data. Perhaps a subject may cheat and copy answers from another, or the sexual composition of the group may alter motivation. Analyzing data. The immediate result of an experiment is a large series of numbers that present behavior under different conditions. Understanding some elementary principles about statistics is crucial to the conduct of psychological research. There are two branches of statistics: descriptive and inferential. Data are usually condensed by descriptive statistics. Descriptive statistics are used to summarize and organize raw data using histograms and frequency polygons. The most common are the mean and the standard deviation. As part of the data analysis, means are calculated for each level of each dependent variable, as well as for combinations of independent variables to show interactions. Inferential statistics allows us to make inferences about the reliability of differences among conditions. Reporting data. Many different styles and formats can be used to report data. The format is given in the publication manual of the American Psychological Association. Study session summary. In this study session, you learn that selecting subjects from some population is called sampling. Random sampling means that each member of the population has an equal chance of being selected. Data collected can be analyzed using descriptive and inferential statistics. End of study session 8. Thank you for listening.